Hello, I'm Lloyd. I'm a software developer for almost 6 years of experience, specifically in JavaScript. And yeah, right now I'm just going to demo on how I work with software development in general. What are the patterns? What are my practices? And specifically on this one is the pattern that I use on software dev. May it be on a large scale or on a smaller scale. So let, let's dive right in. So right now we are on a Node.js environment. This is an inventory system built in microservices architecture. So as you can see here in the file structure, we have the product service, the stock service, the user service. So each of these entity has its own module, has its own server, has its own Yeah, yeah, it has its own server. So basically, they run on different ports, or you could make them run on different server. So yeah, um, so regarding on the patterns that I follow, I think you also know this, Robert C. Martin. This is a renowned software developer. I actually have his book on clean code. And this is the architecture that I follow. So it composes of four different layers, and depending on each layer, varies on depending on what is the system, on how big the system is, regarding also on the time frame. So yeah, basically this would be much more on a coding basis. Like, uh, if the system is not large enough, then we could adjust the architecture. But it is important that we follow a certain architecture in software development because when we go into the code, and we debug it, we write it, we review it once again, or perhaps we onboard a new team member, it would really much be uh, of a help, and like the smooth transitions between debugging, feature implementation, or upgrades. Um, specifically scalability of the code itself. So it makes your code scalable because you know where to look for, and you could see that your code is much more organized than having it written in one block, and like specifically communicating to the database and that one file there, and it also has the business logic inside. Man, that's a headache. I've been there. That's why I could relate to that one because I've been there. Like, I have a project before that where I started to use clean code in this architecture. It's because at first, I was just overwhelmed on writing those directly on um on the module file. Like, I have my business logic in there. I have the code in there that writes to Firebase. I have a code in there that writes to SMTP, all in just one place. And man, when I go back there, like 5 months just to update something, it took me quite a while just to trace the logic. Like, I said to myself, like, man, why did I why did I write this code this way? It looks messy, and it's very unorganized. Like, just one look of the code, it's very overwhelming. So yeah, this is the reason why I follow this architecture now. It separates the business logic. So as you can see here, it separates the business logic. Here is your core, the application business rules. So yeah, here the entities of your application. The entities are um the objects involved. Like for example, in our inventory system, so we have product, we have stocks, we have users. So, uh, so they can have um, the model of a product, like the ID, name, description, the stock, the model of the user. So basically, that describes a certain entity. And also the use cases. Use cases are the actions that your application uses. So, for example, on the product, what actions that involved in the product? Creating a product, updating a product, deleting a product, adding a tag of a product. So particularly the use cases are the verbs of your whole application. So the verbs of your whole application. Entities are the description. It describes the entity of of your application, like the product, the stocks and the users. So controllers, gateways, and presenters. So this criteria here are the interface adapters. So the interface adapters are more likely they will be the one to receive external communication. If you so The external communications would be the frameworks and the drivers as explained here. So the database, the libraries, if you're using SMTP, if you are using Mailgun or any any codes or libraries that is outside of your application logic, so that belongs to the outer part layer. And the interface adapters are be the one who will receive those outside data. So this more likely are abstractions that you can use so that your business logic would remain untouched, and at the same time you could receive data from external sources. So more likely this is where the hexagonal architecture comes in, the ports and adapters. So the main idea is here, your use cases, this part right here is um, your application, and the controllers here are your adapters, and the external layer here are your adapters. So more likely, if you go change adapters, um, you would just change adapters and the ports will remain the same. Okay, so if you go change to Firebase, to MongoDB, to Prisma, to Postgre, your core logic would remain untouched. Okay, so so your app is much more scalable that way. So yeah, that's the hexagonal architecture that comes in. So basically, I have started to also dive into this is where I understand clearly regarding on the clean architecture is when Nicola Lazar explained it in the Next.js. So I also have a separate video with this one on how I follow this architecture also, and how it should look like if ever the project is small or scale. I mean, it scales between the projects. So I also have uh I also have a different video for this topic. So yep, let's dive right into the code. So right now we're just gonna be tackling on the product service. Um, yeah. So first off is we go into on the diagram. So there are three layers. The core logic, the adapter, the port, and the outer layer is the adapters. So this is how I envision when, for example, we are on a small to medium scale of an application. So yeah, so we have only the core, we have only the core, which is here, the business logic, the ad the adapt the ports, and the adapters. So we have only three. We have only three: business logic, the ports, and the adapters. So here we have the entities. So okay, we are on the product service, and yeah, first off, we're gonna tackle on the core itself. So on the core, um, yeah, we have the model. I'm using Zod as a schema definition and also for its validation. So I have here described on a product. So I made the ID union string and number here because I'm gonna make it support Firebase also. And Firebase uses UUID v4 for their IDs. And number for the relational database systems, PostgreSQL, uh, yeah, yeah, with those traditional databases, they use number as an ID. So we have name, description, date updated, date created, and here is just we export the type product so that I could cast this type on an object or an array of object on our use cases or repositories. And it just describes out the product schema. So we have here an insert schema. So I dedicate a certain schema for insertion. This is because when we insert a product, we don't usually require the ID because the ID is being given to us by the database. So in Firebase, this is automatically be done. And if you're using MySQL, I mean SQL databases, um, pretty much likely you have this auto incremented or yeah, depending on the case. So, but as just for this demo, with just the typical um, scenarios. So we just have the name, description, date created, and date updated. So same goes for the product insert here. I just uh, describe out the type so that I could cast it. And we also have a different schema for the updating. So the that omit here is a different one from pick. Uh, this omit here means that uh, I excluded the date created against this schema because when we update the product, we only needed this parameters here because we don't need to change the date created because once it is created, that is the date it has been created. So yeah, same goes for the product update type here. And yeah, so here is the definition of our product, and this is also serves as the validation of it and the schema definition. So here is the product repository interface. So interface is just more likely an abstraction of the product verbs. So the create, the get all, the update, delete. So the keyword that I like the pointers that I have instilled on creating interfaces is that here you define on what that certainty, I mean, you define that entity, um, I mean, you define the verbs of that certain entity. So, for example, on the product, so we have create, we have update, we have delete, and we also have much more depending on your business logic. So, which more likely this just explains on the actions that were done on that certain entity. So yeah, this is important because when we go into uh, the repositories itself, so this is on, so the entities here is the core belongs into the core layer, the business logic of your application. And let's skip the repositories for now because that is on the outer layer. So the use cases also belongs in the core layer. This is where the validation comes in. So here is my index file. So as you can see here also on the use cases, what I did is on each REST API here, on each REST request here, I have made it a file that is only serving one purpose. So I think this belongs to the single responsibility principle. This is because I've I'm much more likely easier to read with this kind of approach. Okay. So in this approach, like if I go to create, to delete, to get a single, to update, see how the number of lines that are just elaborated here. Like I could see here a certain action, and that action and that body of the action here, the scripts that belongs here are just solely for that purpose. S- Because if I go like have a single file here and have it around like 50 or 100 lines of code, and if I go back there and like say a couple of months ago, that would give you like more of um an overwhelming reaction. And also if you go onboard a team member and like he could see a single file that enumerates all of the REST APIs there. Like it is hard to follow. Yeah. So this single responsibility is also good for code readability, and also this makes your code maintain reusable. So I'm gonna explain that on the later part. So here's just creates the product. It receives here on our index file on the post request. So the create product is being imported. So it's just been right here, and it receives the request and the response from the Node.js from the Express server. So yeah, it receives a request body. I just added here the object date created and date updated, since on the insert product schema it is required here. The reason why I did this and not on the other part is that yeah, not on the repository itself, because there might be some repositories that handles the date differently, especially with Firebase. So I made it the date to be have it in here, so that so it also makes sense that my repositories here are just being like more like of a dumb function. My uh like my infrastructure here does not know what's inside my application. Vice versa. My application does not know the database that what is going to use, or the characteristic of the database. Like these two are different worlds. Okay. So yeah, it's important to separate those out, because it would cause conflict on a later part. So just as I explained earlier on the video, that you should separate your business logic with your infrastructure or your external layer. So yeah, so here is just parsing out um, the request data if it matches with the schema. And yeah, so if we go test it out on the Postman, so let's first test it out on like on all of the APIs. So yep, I forgot to run the server. So yeah, we are running on 3000. So if we get all products, and note that I'm using mock repository. So the repositories here is on the outer layer, on the external layer. This is the external layer. And yeah, we are using a sample array um just for the mock database data source. So we have uh yeah, we have the getting of all products. We have the inserting of product. If we go have this uh insert data fields. And if we go get all products, there, boom. If we go update the product, like, I'm gonna update product number 2 to the pencil updated 2. Then we go get all the products again. Here you could see pencil updated 2 with the ID of 2 here, and here are the name and the description. If we go get a single product, I could see it there. Go change it to another product. I could see it right there. And yep, it matches with all the products that we have. And also if we delete a product and get it all again, yep, so we only have one. And if we go change a product that does not exist, let's say ID 200, obviously this product does not exist. It would just throw product does not exist. So same goes for the deletion. Product does not exist. Same goes for the getting all of all products. As you can see, also see this returns null. So I'm gonna explain this why I did this. So yep, all of those REST APIs are can be found on the use cases. So yeah, so here is for the create, and here is for the delete, for the getting of all products, for the getting of single products. So here are so on the use cases here you add the validations of your business application, and yeah, this is for the update also. Yeah, so this is where the validation comes in. So before the data goes into before the data goes into your infrastructure layer, we must make sure that the data is validated before it goes into the infrastructure layer. Because as I said earlier, the infrastructure layer does not know anything about your business logic. So your business logic must be remained under your business logic on your core itself. So before you add there the data, you must make sure you have done all the validation there. And it's much more easier to read and to follow because let's say if you missed out, like for example here, and you know that the architecture that you follow is this one, you would know that anything that regards on an error, you would know that the error would not happen on your infrastructure layer. It will be obvious. Like, dude, it will be obvious because like for example, if I update the product, let's say this one, boom, like it says here updated date, uh it expects a date for the date updated object, but it receives undefined. You know here that the error comes from the business logic, not from the infrastructure layer. Because like if you're gonna use Firebase or some other DBMS, you could see the error that are specifically on from Firebase itself. You could see errors that like the description of the error, like Firebase error. Firestore error. If it's in the MySQL error, they have different errors there. So you could distinguish the errors there. Like if it is coming from your business logic or if it's coming from your uh, infrastructure layer. And you would easily distinguish this because you made those two different layers separated. So yeah, that's the point there. So and also with this one, as you can see in all of the CRUDs here, I just use the product repository, uh, this like the single product repository here. Sorry. So right here, here is the main product repository. So we are now going into the infrastructure layer. So yeah, this is much more likely what is inside. This is I think as I know what I have researched, this is a factory repository because you could here switch out from different repositories. So you could have Firebase, you could have Prisma here, you could have MongoDB, for example. So you could have different data sources or repositories around here. So yeah. Um, so here it just enumerates all the action that was on the interface of product repository, which is coming from our core from our business logic. So which defines the verbs of our app. And yeah, on this one, this is okay. So you might be wondering, um, why is my uh why is this business logic related gets into our repository, gets into our infrastructure layer. Okay, so you might be wondering why. So this right here is a connection between port and adapter. So this is the bridge between those two. But the thing here is that this repository does not know what are happening inside the creation of products. Whether it's valid, the infrastructure layer here does not know um, what validation did you use in your in your in your application, because what it does, as you can see here, because as for now we are using mock only, so we are going to do a product mock repository. As you can see, it just pushes the data. Okay, so we're just mocking the insertion, so it just pushes the data. And for the deletion, it just deletes i that product with the equivalent ID, and it just deletes from the array. The getting of products, the getting of all products, it just returns all the items on the array. So here, as you can see, I have no logic here that relates to my business logic. Okay, that's the thing there. I have no logic here. I have no code here that relates to the business logic, to the application. So what it really does, it's just this what this does is just it just communicates to the data source. And by doing so, it just follows out the abstraction of the interface. So the create, the get all, the update, the delete product. So that is also the reason why I'm fond of using TypeScript, because it makes you less it makes you force yourself to write this code this way to prevent more errors. Yeah. So it helps you code with less errors. Yeah. So yeah. As you can see here on the product repository, this is just a factory repository. So um, depending on what object that I use here, um, this will be used on the database as a data source. So if I have Firebase here, let's say for example Firebase, and if I go change into Firebase, this would be automatically, oh, this is having an error because it must receive an interface of the product repository, which is having this verbs. And yeah, same as like with this one on the product repository, on the mock repository. So yeah, um we have here enumerated all the all the actions that were described here. Because if we go delete that single thing there, it would create an error saying that it requires the update product verb or function. So yeah, and yeah, so also on our use cases, it just it just automatically cascaded into uh depending on what repository that we are using, because I'm just instantiating the repository here uh based on what it's exported. So let me remove that, clear out this error. So yeah, pretty much it would cascade on the creation, on the delete, the get all product, the get, the update. And what is also good in this way, because let's say if you have a team of developers, you could assign uh, a developer to work on a certain repository. Say for example, you work with Postgre, like it will be on Supabase, for example. You could have one developer working on the infrastructure layer to implement the creation of an entity for a product itself. For example, sorry. So like the creation of product, the deletion of product, the getting the get, the update. So write those um in in Postgre or in Prisma. Yeah. So you could have those. I mean, you could have them working separately without touching each other's toes, because your other developer could be working on the business logic, and say if he wants to work on with, like for example on um if he wants to test his logic, like he could just create a mock repository out of that, so he can work independently. Because once the other developer finishes on like the Prisma repository, then what he could do is just uh to change it around here. And so that lessens the conflicts, and much more likely segregates the tasks there. And yeah, so this one right here promotes the app to be much more scalable, because you could not only just apply this on data source, you could pretty much apply this on external libraries like SMTP libraries, or messaging libraries. So if you ever to change a different library, then you would just having the same way. Like you would not touch your logic every once in a while um if you change external libraries, because pretty much your application would adapt because you follow um like the ports and adapters hexagonal architecture. So yeah, if your adapters would change, the ports would remain the same, and in the receiving end. So yeah, So I think I have explained all the parts here um on how I work with software development. So this is on Node.js with Express, and we are on a Node.js environment with the microservices architecture. And I'm gonna also tackle uh, the microservices implementation and the ups and downs of it on a separate video, like explaining on the other services. Or much more likely, this is much more this is pretty much the same. So like on the services, but yeah, I'll be I'll be on that one on another video, and also on Next.js with clean architecture and some modifications into it based on the system the system requirements, the time, and like the number of teams. So yeah, because I have also experienced based on my experience that uh pragmatic development varies also on uh like on the company itself, on the project itself. So yeah, but is so you must be like just in the middle, like you could still follow the timeline, the sprints, and the team synergy, and at the same time you also have followed clean coding because yeah, this is pretty much more like it would help other developers and yourself in the future. But you should not be too much like uh you shouldn't be too much pragmatic on with this one, especially if we have a tight timeline. Yeah, I've also experienced that also. So yeah, with this one, this is just pretty much simple uh structure. We have only uh three layers here, and pretty much this is a scalable one. So yeah, see you on the other videos, and please give me some suggestions or comments on regarding on what you find that needs to be like enhanced or to change. I'm open to suggestions and comments. So thank you.